Hi everyone, welcome back to another Blender tutorial. In this video we're gonna talk about rendering with Blender. That means we'll tell it to generate a picture for us that we can actually save to our files. That is actually super easy to do. You just have to press F12 to open the rendering view, and then it will draw a picture out of the scene and the current camera, direction, and settings. And then we can save that. Here, image, save as, there you go. Okay, but it's obviously not just that easy. There's a few things that we should talk about that explain a bit what's actually happening here. So first of all, why is this so fast? Rendering is supposed to take a long time. And that mainly relates to the fact that I don't have a lot going on here in my scene, but also that I'm using currently the simple rasterization rendering engine called Eevee from Blender. Blender has also a much more advanced and high quality render engine called Cycles that is a path tracing engine. So let's have a look at these render engines and how to change between them and what they do. Close the render view here. To change render engine, you want to go to the right to the properties here to render. And there you can see currently I have Eevee selected. And that's again the rasterization render engine. And I can change that to cycles here. And now we use the path tracer. And we can immediately see that changes everything how the objects are rendered and represented even in work view. Between the rasterization engine Eevee and the path tracing engine Cycles, we have to talk a little bit about what rasterization and path tracing actually does. So the act of rasterization means that we basically, when we draw, or when the computer draws any 3D objects made out of polygons and triangles, it looks which of the triangles overlap what pixels on the output image, and then it colors in those areas based on the materials that we assigned to the object. A ray tracer, on the other hand, and path tracing, like Cycle is a path tracer. Path tracing is just an advanced version of ray tracing, but it uses much of the same principles. So ray tracing instead actually shoots rays from the virtual camera, in this picture here noted as the viewer, through our image plane, that's basically in front of the camera, that's how we take the virtual image, into the scene, and then see which objects collide with that ray. And then we can follow the ray's path back to the light source. And along its way, it can reflect on many objects. It can also refract, like here on this sphere, which is translucent. And we can actually get a much more realistic picture with that. So in rasterization, we don't actually trace any light rays around the scene. The lighting is calculated basically indirectly by just very simply calculating the angle to the light source of every surface. But in ray tracing, we actually follow the light rays around. That's way more computationally expensive, and it's also quite heavy on our computers, as we will see when we use it. But since we trace the light rays around and the objects that they interact with on the way to the camera, we can actually do things like reflections and refractions much more easily than rasterization, and some effects are not even possible at all with rasterization. Okay, so now back in Blender, let me change the rendering engine back to Eevee, and then hit F12. There we go, we render. This took 18 milliseconds. And then I'll have a look how long it will take with Cycles. Change to Cycles and then hit F12. And now we're just gonna wait a little bit until this is done rendering. There we go. it took 1 minute and 3 seconds to render this image. And wow, does it look better than the rasterized one. Ray tracing is way superior when it comes to graphics quality, of course, than rasterization, if you have the time to draw the images with it. That is why almost all CGI in movies is rendered using one or the other version of a ray tracer or a path tracer engine. Okay, but now let's unveil the real power of ray tracing, and that would be reflections and something called global illumination. For that, I have changed our setup here a little bit, and I'm also using Eevee right now to do that, to have a fast sort of work environment. And by the way, if you wonder how I got these cylinders to have smooth edges, by default that's actually not the case. If you add a cylinder, right, it's like edgy. You can see here. You do that by right-clicking it, and then you say Shade Outer Smooth. And then it can interpolate the lighting on the edges that you want to be smooth. Okay, but let's not get sidetracked. So back to rendering. For the cylinders here, the yellow ones, if I go to the Material tab, you can see here I'm using the principled BSDF we talked about in the last video, but I actually set the metallicness to being almost 1 and the roughness to be 0 for this material. And that means that it resembles some sort of gold-like surface. So it should reflect its environment. It's not doing that right now because Eevee can't render that. So even if I press F12 here and draw the scene, we don't have any reflections. So let's see what happens if I switch to cycles. Of course, it's gonna take a while to render, but even in the preview already, we can see our reflections working. I have one reflection. If you look very closely, we can actually see the reflection of the reflection of the reflection of this red cylinder in the middle, bouncing back and forth between the two golden ones. So last thing would then be the global illumination I mentioned earlier. Global illumination basically means the interaction of light bouncing around the scene and transporting light from one surface to another. If light hits a red surface, it reflects as red light, and then if it bounces off another surface, that surface would be illuminated red from the light that comes reflected from the red surface. So that means all of the surfaces close to a red object should have a little bit of a red hue to them. And we can actually see that here in cycles around the shadowed areas of the object. So if I go and zoom in here, very close to the shadow, we can actually see that the shadow color is partially illuminated yellow and red from the two neighboring objects where the light bounces off those objects and then takes on that object's color and gives that to the shadowed area that doesn't get any light directly from the light source. So there you have it. That's Eevee and cycles, rasterization, and path/ray tracing in a nutshell. Just to finish this off, I want to say one more recommendation for you if you want to try this out. I recommend that you go to the Output tab here and change your output resolution to something that's not high res, because it's gonna make the generation of those images a lot faster. So I have 800 by 600 here. You can make that even smaller. And of course, you can also, in the render view, mess around a bit with all of the sampling settings here for cycles. That means like how many rays per pixel are going to be processed and how many jumps between objects do you recognize. And that will speed up your rendering quite a bit as well.